We are diving into a section now that is called functions. And in order to answer questions on functions, it's so important to have a good grasp of the notation that gets used. So this is a new thing for us here at grade 10 level. F of x is how you pronounce something like this. So you'll read that f of x. And basically what it's talking about is y as a function of x. And so what happens is this whole f of x can be interchanged with y. And if you remember that, you'll be okay. So if they say to us f of x is equal to 12x minus 15, then this we can equate to our grade 9 knowledge where we just said y is equal to 12x minus 15. And we can say, that is a straight line graph. Okay, but function notation is extremely useful because we can actually use it to find specific points on the graph. In other words, if I wanted to know, for example, what does y equal to? So what is y when x is equal to a specific number? So let's say when x is equal to 10, how much does y equal? And then what we'll do is we'll use this function notation and we'll say, well, we want to know what is this as a function of 10, and everywhere that I have got an x, I am going to substitute in the value of 10. So we're going to say that's 12 times 10 minus 15. And then we work that out. So it's 120 minus 15, which is 105. And the reason we like it is because it gives us coordinate notation. So what we're looking at now is an x coordinate and a y coordinate. And we can put that in a form where we can say 10 and 105. And then those are coordinates on the Cartesian plane. So function notation is extremely helpful. It's very important that we understand how to read it. And it's very important that we don't let it freak us out. We just need to know that f of x is representing y as a function of x. Now there are 4 types of functions that we are going to be learning about this year. We'll start with the straight line, and we'll focus on that in this video. And that's something that we have seen in the past. So the equation for the straight line is y equals mx plus c, or you may have seen your teacher using y is equal to ax plus q, and that's okay too. It just means that they are using slightly different variables there for the gradient and the y-intercept values. And then the other functions we'll look at is the parabola, the hyperbola, and the exponential graph. And it's very important that you understand the difference between the 4. So if you're given a graph that looks like this, you need to know that the equation would be in the form y equals mx plus c. Okay, and we're going to take time to focus on each of these different functions in the videos that follow, so make sure that you watch all of them. This video is going to focus specifically on straight line graphs, and the standard form that we use most commonly for straight line graphs is this one, y is equal to mx plus c. And we need to know certain things. The m value in this graph tells us what the gradient of a line is, and the c value of this graph tells us what the y-intercept is. And so these types of graphs we are going to see all the way through till the end of matric. And so it's very important that we are familiar with them and that we become quite quick at working them out, because we want to save time for some of the more complex types of graphs. Okay, so if we get a graph like this, as I said earlier, it's not a problem if the teacher decides to use A to replace the gradient and Q to replace the y-intercept. Those are variables, and so by nature we're allowed to use different letters to represent different things. But this is the type of formula you can expect to see on your formula sheet at the end of matric, and so it's nice to get used to that one. Okay, gradient is closely linked to the concept of slope. So let's have a look at the 2 main differences between slope. If you have a line that is increasing, so in other words, as you travel along the x-axis, you'll notice that the y values are getting bigger and bigger. That's called an increasing slope. And what we need to know about that is that our gradient, so our m value, is bigger than 0, which is just a fancy maths way of saying that we are dealing with a positive gradient. On the other hand, if we notice that the line is going downhill, in other words, as x moves forward, y is becoming smaller and smaller, then that would be known as a decreasing line, and our gradient is negative. Okay, and again, we can simply just write that as a negative m. It's just that sometimes, because m is a variable, it's better off if we understand this notation. So greater than 0 means m is all the numbers bigger. So think about numbers bigger than 0. 1, 2, 3, 4, 5. Those are positive. Or m is smaller than 0. That means negative. Think about numbers that are smaller than 0. Minus 1, minus 2. So those are all our negative values. Okay, so we've got our standard form. We know that the gradient can tell us what the slope of the line is. And our y-intercept would then indicate to us where it cuts the y-axis. Okay, so that brings us to our next point here, which is the intercepts point. So either to get the y-intercept, we can simply say y equals the c value of the graph, or we can use a method that works for all graphs, and we can let x equal 0. So if you were to sub a 0 into this equation, you would discover that y does actually equal to c. So that works out. And if you need the x-intercepts, then we do a very similar thing where we let y equal 0. Okay, and that makes perfect sense if you can picture a straight line graph. Have a look at this small one over here. So a y-intercept is on the y-axis, and that, if you follow it down, is where x equals 0. And so that's why we do that. And an x-intercept is on the x-axis, and on the x-axis, the y value is 0. And so that's why we do that, to work that out. Okay, and then we are introduced to this new concept of domain and range. So domain, that is all of the x values for which the graph exists, and range is all of the y values for which the graph exists. So if we consider a straight line graph here, what you hopefully can see is that if you follow this line all the way, it goes all the way until infinity in the negative direction, both for x and for y. It's going to continue in this sideways direction, which is moving negative in the x and negative in the y, and in the same way all the way through to the positive infinity for x and y values. So you'd be able to carry on going, and you'd find values of y all the way for x and for y. So we can then write this down and say this graph exists for all real numbers of x, and it exists for all real numbers of y. And so if we are asked for the domain and range, that's how we need to answer these types of questions. Where does the graph exist? It exists everywhere. Okay, and there are a couple of different notations you could use. So if you would be more comfortable to say x is between minus infinity and infinity, and then the same thing for y, that's 100% fine. Or you could use interval notation where you say x is an element from minus infinity all the way up to infinity. And all of these things mean the same thing. So your teacher will give you a mark for that, or for that, or for that, as long as you understand what you are representing. Okay, let's move on from the theory into a more practical, or the more practical part of this section, and that's where we get to sketch graphs. So here we are asked to sketch this graph. It's a function f of x is equal to 2x plus 1, and we are given a set of coordinates here. So the first thing we should do, if we're not given one, we need to draw one, but we need to label this. So 1, 2, 3, 4, 5, that's our x-axis. Okay, and we get marks for labeling things like intercepts and turning points. And so by labeling these axes, we are already setting ourselves up for success. Okay, that's the y-axis there, and then minus 1, minus 2, minus 3. We go on here in the negative direction. Okay, so we've got our axes drawn. Please, if you need to draw them for yourself, make sure that the spaces between the numbers are equal. Okay, although it says here sketch, in maths, we're not here for a creative arts project. We need to make accurate sketches. Okay, what we need to do now is we need to take a look at this equation that they've given us. So f of x is equal to 2x plus 1. So what we know already is that this graph is an increasing graph. I can look at this equation and I can tell that straight away. And it's got a y-intercept here of positive 1. So I've already got some good information here to help me draw it. What I like to do is I like to use the dual intercept method because it's something that is going to work for most of the other graphs that we're going to encounter. So we want to get an x-intercept. How do we do that? Remember, it's on the x-axis, so we're going to let y equal 0. So we're going to take our equation, and now you might say, oh, but there is no y in this equation. But remember that f of x can be written as y. So y is equal to 2x plus 1. And then to get our x-intercept, let's say 0 is equal to 2x plus 1. We're then going to move this 2x across. So that's going to be minus 2x equals 1. Let's divide both sides by minus 2. And so we end up with the fact that x is equal to minus a half. So what I can do now is on the x-axis, I can look for the point minus a half, and I can plot it there. I've got an x-intercept. Okay, and we're going to label that soon. Let's get our graph in place first. Okay, dual intercept means there must be two. So we've got an x-intercept and a y-intercept, which we can read so perfectly from the graph. We don't even have to let x equal 0. So y straight away is equal to 1. So then on the y-axis, I can plot that point. And once I've got my 2 points, I pick up my ruler and I draw the line. Now this line is going to go on forever. So I need to add my arrows and I need to label it. That's the line F. Okay, we also need to double check. The question will often say we must label all turning points and intercepts and asymptotes. Now in this case, this kind of graph just has intercepts. So this one is labeled because we did label all the whole numbers on our y-axis. But this one here is not labeled because it's a half. So let's add in there the fact that that point there is minus a half and 0, just to show that we fully understand. And then make sure that you've labeled your graph, and then you are good to go. There are 2 special cases that we need to know about, and those are what I like to call y lines and x lines. And what they are essentially is just lines that are parallel to, in this case, the case of a y line, they're parallel to the x-axis, and in the case of an x line, parallel to the y-axis. And in order to draw these, you'll need to find this point on the y-axis. So y is equal to minus 3. Let's get our increments in there. Minus 1, minus 2, minus 3. And then, with your ruler, you can draw that line. So if you try to work out an x and a y-intercept, you will find a y-intercept, but no x-intercept. And so you'll see that might be tricky then to draw if you don't recognize that this is a special case. Okay, the line x equals 4 will do the same thing. So let's say that's 2 and that's 4. On our x-axis, we want to then draw the line there that cuts through. And this is the type of line that we would see there's no y-intercept because it is a special case. Okay, if we want to get all of our marks, we need to label. We need to say this is the line x equals 4, and it's going to carry on. And this is the line y equals minus 3. And we've got our arrowheads in place. Okay, so learn these. One thing that you could do if you got very nervous is you could go back to the table method and you could calculate for each x value, although you'd see there isn't even a space to substitute in an x value, so I strongly encourage you to learn these special cases. But if you wanted to, what you'd find is that every x value that you substitute in, you would always end up with a y value of minus 3. Okay. And then finally, let's have a look at parallel and perpendicular lines. So if you look here, the two red lines in this sketch are parallel, which means they're traveling in the same direction at the same slope and will never ever meet. And what we'll notice is that parallel lines have got equal gradients. And if you look at those two equations, you will notice that they are both equal to a third. So in this case, it's absolutely true. These two lines are parallel because their gradients are identical. Okay, and then just for interest's sake, you can see the y-intercept there is 2. And because there's nothing written here, that's okay. That means the y-intercept there is 0. And then if we look at perpendicular lines, so in other words, this blue line here is perpendicular to the parallel red lines, then what do we notice about the gradients? It's actually very interesting if you take the time to have a look. The sign is different, so that was minus, this is plus, and then this is actually what we call the reciprocal. So this could be written as 3/1. So it's the negative reciprocal, but there is an easier way to remember that. So we can say perpendicular lines, and then we can say their gradients multiply to equal -1. And we can actually test it out. So let's take the blue gradient, which is 3, and we're going to multiply it by just one of the red gradients. We don't need to do both because we're just looking at the perpendicular lines there. And if you check them out, 3 multiplied by -1/3, that's 3/1. Positive times negative is negative. 3/1 times 1/3 is 1. So that is true. So parallel lines, equal gradients. Perpendicular lines, the gradients multiply to equal -1.